Understanding dynamic and static typing.
Dynamic and static typing are two fundamental approaches in programming languages. They define how and when a language checks the types of variables and values. Understanding the difference helps programmers choose the right tool for their projects and can affect how they write, debug, and maintain code.
What is static typing?
With static typing, the type of a variable is known at compile time. This means programmers declare variable types before the program runs, and the compiler checks types for correctness. Languages such as Java, C, and Rust are statically typed, helping catch errors early, but often requiring more upfront code for declarations.
What is dynamic typing?
In dynamic typing, variable types are determined at runtime. Programmers do not need to specify the type when writing code. The language figures it out as it runs. Python, JavaScript, and Ruby are examples of dynamically typed languages. This can make code faster to write and more flexible, but it may lead to runtime errors that are harder to predict.
Advantages and drawbacks.
Static typing provides strong checks at compile time, which can prevent many bugs before the program runs. However, it may make rapid prototyping slower. Dynamic typing allows for quick experimentation and concise code, but can result in hard-to-find errors that only appear when the program is running.
Why typing matters in programming.
Choosing between dynamic and static typing affects code safety, speed of development, and error detection. Some projects, like large software systems, may benefit from static typing's reliability. Others, such as quick scripts or prototypes, could gain from dynamic typing's flexibility. Understanding these differences helps developers pick the best language for every job.